Hi everyone, welcome back. Today we're doing find first palindromic string in the array. So we're given an array of string words and we have to return the first palindromic string in the array. And if there's no such string, return an empty string. A string is a palindromic if it reads the same forwards and backwards. So in this case, adder, in this case, is a palindrome. And car is not a palindrome because the opposite of car would be rac, R-A-C, so that's not a palindrome. So in this case, if we have words like this, then in this case, the first palindrome would be adder. ABC is not a palindrome, car is not a palindrome, but adder is a palindrome. So we return adder. For the second example, we have a list of two words. In this case, race car is the palindrome. Not a palindrome is not a palindrome, so we will return race car instead. And for the third example, we are given a list of two words. In this case, both words are not palindromes, so we return an empty string. The constraints in this case is if words is the list of strings containing words, then this list can range from 1 to 100 words, very lenient. And each word inside this list would have up to 100 characters or at least one character. And thankfully for this question, we only have to deal with lowercase English letters. So to do this, we can do a linear scan across the words for word in words. And for each of these words, we can get the palindrome, like the reverse word, using a technique of string slicing. So if you want to get the reverse of a word, we can just do this string slicing syntax over here. The first parameter is really 0, and the second parameter is really the length of the word. And in this case, the third parameter is the step. So the step means how many characters, like how many characters, like what's the, do you want to go forward or do you want to go backwards? So if you specify it as 1, which is the default, then it will go through each character one by one. And in this case, like if we specify -1 and we do not specify any parameters, then the string slicing will be smart to know that actually, oh, you are actually wanting to reverse, you actually want to go through this word backwards. So you iterate from the back of the word in this case, and it will start moving all the way till it reaches index 0. And it will do it with a step of 1 backwards. So it will go from the right to left instead. So in this case, if you have a word, let's say adder, this is really, then in this case, the syntax for this string slicing, in this case would really be length of word up to -1 index and with a step of -1. So the length of word in this case would be, 3. So 3 minus 1 will give us 2. And it will iterate from 2 to -1 exclusive of -1. So it will go 2, 1, 0. And the reason why it's going from 2, 1 to 0, that's because we specified a step of -1. So in this case, it will iterate adder at index 2, index 1, then index 0. So in this case, that's pretty much how string slicing works under the hood. So hopefully this makes it clear for how we can get the reverse of a word like this. So as you notice, in the first syntax over here, we didn't specify the first and the second parameter. It's because if you do not specify it, then the syntax, the numbers that is filled inside this string slice would be defaulted to the length of word -1 to -1. If we specify a step of -1, it will just return back the word, but in reverse order. So if this word is equals to reverse word, then in this case, this means that this is a palindrome. So if that's the case, we will return the word itself. Otherwise, we will just return an empty string like this. So this is pretty much the algorithm for this question. So let's try this test case over here. In this case, word will be equals to ABC, and the reverse word will be equals to CBA. So since word is not equals to reverse, this is false, we will continue with this for loop iteration and move on to the next iteration. So next we will see car, reverse word will be RAC. This will evaluate the false because word and reverse word are not the same. And now we get to the third word. In this case, the reverse of adder is indeed adder, so this will default to true, and we will return this word, giving us back adder. So this is for the first example. For the second example, if we use this test case, we will get DEF. The reverse of DEF will be FED. In this case, this will be false. We will continue with the next and final word, GHI. The reverse is IHG. GHI is not equals to IHG, so this will be false as well. And in this case, because this is false, 6 to 9 would finish, and we will return an empty string, giving us an output of an empty string. So that's pretty much it for this implementation. So let's do it. So let's do forward in words, reverse word as a string, and we will use the string slice of word, but -1 backwards. And if word is equals to reverse word, we return word, else return an empty string. So we traced it previously. Let's run this code. This passes. Let's submit this. And that's it. So if we let n be the size of words, and we let m be the length of each word, then in this case, the time complexity on line 18, around there, I just changed the line number by typing stuff. But in this case, the for loop on line 19 would be on, because if your number of words increase, then the number of iterations we have on line 19 would scale linearly. On line 20, we reverse the word, and in this case, the string slicing to get the reverse of the word would take some time as well, and this would be OM. The longer the word, the more time it would take to reverse that word. The string comparison is O1, and in this case, that's negligible, that's O1. So in summary, the time complexity will be O and M, where N is the size of the word and M is the length of the word. For the space complexity, in this case, the space complexity is keeping track of the reverse of the word, and this variable is overwritten every time on every iteration. So that variable is still shared. So the space complexity, the reverse of the word, is used to store the reverse of every word. So the space complexity will grow with M, which is the length of the word. The longer the word, the more the memory that's used on line 22 to store the reverse of the word. So this gives us a space complexity of OM. And that's pretty much it for this question. If you find this useful, please give us a like and subscribe, and we will see you in the next video.